Alright, we're starting section 4.4, which is trig functions of any angle. So that would be any angle theta that's on at point x, y on the terminal side of theta. So this is when you are not on the unit circle, so your radius is something other than 1. So remembering that sine was y on the unit circle, it's also going to be y here, but we have to take into account the radius. So our sine is now y over r. Cosine will be x over r, and tangent has not changed. It's still y over x. So let's flip everything else. Just remembering that when we're not on the unit circle, we have to incorporate our r. So here's a point -3, 4. This is obviously not on the unit circle. So the first thing that we need to do, we have x, we have y, we need to find r. And our equation for r was up above, the square root of x squared plus y squared. But just think of it as the third side of a triangle. You're always doing the square root of both other sides squared and added together. So the square root of -3 squared plus 4 squared, or the square root of 25, or just 5. So find sine, cosine, and tangent is our goal here. Sine is y over r. Cosine x over r, and tangent is y over x. Okay, so this is going to be a helpful little tool for you to use to remember in which quadrant all of our trig functions are positive or negative. Remembering ASTC, or all students take calculus, or whatever you want to use to remember those 4 letters, they stand for all, sine, tangent, and cosine, and that's referring to the different quadrants where we are positive. So all, that's starting in quadrant 1. That means that all of our trig functions are positive here. So sine, cosine, tangent, all positive. As we go around, we have s, which just means that sine is positive. So cosine and tangent would both be negative. T, ASTC, remember? So going back to all 3 of our major trig functions, tangent is positive here, but sine and cosine are both negative. 4th quadrant is C, which means cosine is the only positive trig function in that quadrant, other than its reciprocal. Of course, secant is still going to be positive there. So this is going to be something you want to remember. That's going to ensure that you have the correct sign, whether positive or negative, on each of your trig functions. So given that tangent is -5/4 and cosine is positive, find sine and secant. So recognizing that tangent is negative and cosine is positive tells us that we are in quadrant 4, ASTC. Because if that's where C is positive but T is negative, that means we're in quadrant 4. So we need to figure out what y and x is. We know it's tangent is y over x, so we need to figure out which one of these, the 5 or the 4, would be negative. X is not going to be negative because cosine's positive, so we know that the y value is what's going to be negative here. So that's going to be an important thing to note. So now from that we can figure out our r, the square root of x squared plus y squared. And we have a square root of 41, which does not simplify, so that's our r. We need to find sine and secant. So sine is y over r. Can't leave it that way, so it's -5 times the square root of 1 over 41. And secant we're looking for, which is r over x. Okay, so we want to leave our answers in exact form like those two. Okay, reference angles. We have 3 different situations for a reference angle. A reference angle is always acute, which means in quadrant 1, a reference angle is just itself, but we have the 3 other quadrants to try to figure out. So we'll start over here with quadrant 2, saying we have an angle in quadrant 2. Here's our theta. We're always trying to find the angle from the terminal side of theta, which would be right there, to the next horizontal axis. So our angle, let's do a different color here. Our angle for our reference angle would be right there, and we would call that theta prime. That's how we identified the reference angle. To find that in the quadrant 2 in radian degrees, we would take pi and subtract off our angle. Or in degrees, we would do 180 minus our angle. Okay, quadrant 3, my angle would end over here. So remember, we're trying to get back to the horizontal axis, so we actually have to go backwards on this one to find theta prime. The equation for theta prime in quadrant 3 is to take our angle actually and subtract off pi, since our angle is going to be bigger than pi, but we want to figure out what that difference is, or subtract 180 if we're in degree mode. Oops. There we go. And last one, quadrant 4. Our angle is all the way around there. Our theta prime gets us back to the horizontal axis. So on this one, we would take 2 pi and subtract off our angle, or 360 and subtract off our angle. So to find the reference angles, first I need to know which quadrant I'm in. 300 degrees is in quadrant 4, which means I'm going to take 360, since I'm in degree mode, and subtract off my angle 300. Theta prime would be 60 degrees. 2.3. So it's tough to figure out which quadrant that's in. It's helpful to recognize, and this is kind of a trick, helpful to recognize that, here I'll draw a little quick picture here. Pi over 2, if I was to figure out the decimal approximation for pi over 2, it'd be about 1.57, and pi would be the same thing as 3.14. So if there's no actual pi in our angle when we're in radian mode, see there's no degree symbol, so I know I'm in radian mode. If I am in radian mode and there's no pi, I might want to just use these quick tips to help me figure out which quadrant I'm in. 2.3 is between 1.57 and 3.14, so I know I'm in quadrant 2. So to find theta prime, I'm going to take pi and subtract off my angle, and you get about 0.8416. Negative 135, I can't do a reference angle to a negative angle, so I'm going to add 360 to figure out the positive equivalence. That would be a coterminal angle here, and this would be 225, which is in quadrant 3. So to find theta prime, I would take my angle, 225, and subtract off 180, where I would get 45 degrees for my reference angle. Okay, evaluate each trig function. Cosine of 4 pi over 3. So I have to go through a few steps here. The first thing that I'm always going to identify is which quadrant I'm in. 4 pi over 3 is in quadrant 3, just past the horizontal, so we're in quadrant 3. I need to find the reference angle then, theta prime. Because I'm in quadrant 3, I would take my angle, 4 pi over 3, and subtract off pi. So my reference angle is pi over 3. So I should be very, very familiar with the first quadrant. That's what of the unit circle, that's what I want to become familiar with, which is why we find a reference angle here, because I don't memorize the entire unit circle. I want to memorize just a little bit. So I'm going to memorize the first quadrant, and doing this is a helpful way to to help me with that is to just go back to the first quadrant all the time. So the reference angle for this is pi over 3, but I can't just use the reference angle and evaluate that. I need to know if my function is supposed to be positive or negative where it is. I'm in quadrant 3, which means if I think ASTC, this tells me that cosine is negative here. Okay, so I know that my answer is going to be negative, but I can go back to my first quadrant now as a reference angle and figure that out. So cosine is negative, but I want to figure out the cosine of pi over 3. And knowing the unit circle, you got to start memorizing it. Negative 1/2. Tangent of 210. Since we need to find the reference angle eventually here, we need to figure out the coterminal angle first so I know which quadrant I'm in. Add 360, and my coterminal angle is 150, which is in quadrant 2. So theta prime is 180 minus 150, which is 30 degrees. From that, I need to figure out if I'm supposed to be positive or negative. Tangent is in quadrant 2. ASTC is negative. So negative tangent of 30 degrees is negative square root of 3 over 3. And cosecant's a little trickier because we're not used to working with cosecant. Sine, cosine, and tangent are our go-tos. So once we have secant or cosecant, it gets a little tricky. But I need to find an angle that's coterminal with this because 11 pi over 4 is too big. So I subtract off 2 pi, and this is coterminal with 3 pi over 4, which is in quadrant 3. Okay, so find theta prime. I do 3 pi over 4 minus pi. It's the other way around. Oopsies. My apologies. Because pi is bigger. 3 pi over 4 is also not in quadrant 3 is my problem here. It's in quadrant 2. So pi minus 3 pi over 4 is pi over 4. And in quadrant 2, ASTC, positive. So now I just look at cosecant of pi over 4, which would be 1 over square root of 2 over 2, which is the square root of 2. And since it's going to be positive, we leave it just like that. And the last example we have. If theta is an angle in quadrant 2, such that the sine is 1/3, find cosine by using trig identities. So in quadrant 2, I have to figure out, is cosine going to be positive or negative? Quadrant 2, ASTC, it will be less than 0, it will be negative. So my trig identity, we have to think back to a couple sections ago when we used the sine squared plus cosine squared equals 1 identity, the one that we're going to use a lot. So I know sine is 1/3. Trying to find cosine. Just algebra my way through this. Two times the square root of 2 over 3, and I know it's going to be negative because it's in quadrant 2. Somehow the homework snuck onto the top of the next page, right there, but that is section 4.